Well, welcome back and be with me again. In today's lecture, at first I want to address some questions and issues that are raised by students through either email or Piada. First of all, it's about lecture videos. Thank you, Ariana, for pointing out that you can actually watch the lecture videos online without downloading it if you are using Google Drive. And for students who are trapped in China, we have uploaded the lecture videos to Baidu NetDisk, so you can download them from there. And if you are trapped in anywhere around the world and you cannot access either Google Drive or Baidu NetDisk, please email me and I will see what I can do. Okay. There are students who suggest me to use front cameras so you can see my body language during the lecture, and that would be helpful. But unfortunately, it is infeasible for me to use front cameras. So, well, first of all, I guarantee I will not use any body language while recording this video. And I will try to use more drawing and write down more comments with Smart Pen. So hope that could helpful. That could be helpful. All right, that's for lecture videos. For projects, I have received a couple of questions regarding projects. So basically in projects, you will be asked to write functions in Python. In other words, you can use any IDE you like to do your coding. And we did mention Jupyter Notebook or Python notebooks. That is only for specifications and for labs. So you are not required to implement your program in Notebook. But it is your responsibility to make sure that your implementation can be executed in CSE machines, because that will also be where we test your submissions. Okay. And also in the past few days, I have seen some advertisement of Tutorial Institute or private tutor through social medias, especially WeChat. Here, I don't want to comment anything on this private tutor thing, but I do want to point out that this trimester, this course is kind of new. So it's different from all the past 9313 courses. And as a lecturer, I'm new as well to this course. So basically the contents of the lectures would be different. The assignment would be different. The projects would be different. And the final exams would be different, of course. Especially considering this COVID-19 situation, everything's online. So yeah, there are definitely a lot differences between this trimester's course and all the previous courses. So it's up to you, but I do think if you have any questions, the best way to solve it is to discuss with your classmates through Piazza. You can ask your questions in online consultation to discuss them with tutors, or you can email me and discuss your questions with me. Okay, so that, by the way, is totally free. And I think all these people, me, tutors, your classmates, and yourself, we're all working on this course, this subject, almost every day, I guess. And we're all familiar with the new lecture contents, and we all have the same objective. So yeah, I think this is the best way to address your questions. And here, the school, or the university actually, asked me to introduce you this new policy of plagiarism starts in this trimester. So basically, each of the following qualifies as serious plagiarism and will be escalated to UNSW conduct and integrity. This contains the whole or almost the whole work has been plagiarized or copied, or say there is evidence of a deliberate attempt to disguise plagiarism, or there is evidence of contract cheating, which is ghostwriting, I've mentioned last time. And if you did any of this, the outcome could be the fail of the course. All right, the fail of the course, not only the assignment or the project, and suspension or permanent exclusion. So don't ever try any of this. And there is also so-called significant plagiarism. The definition is copying or collusion with large section of work, identical or almost identical. Especially for programming assignments, large is not just a matter of how many lines of code have been plagiarized. It suffices that much of the essence of the program has been plagiarized or copied. And the outcome would be a 0 mark for the assignment or the project. So back to the private tutors, especially when you have one tutor versus multiple students. I'm not sure what they would do to prevent you from copying in sense of the problem. So anyway, just don't do any, don't violate the UNSW conduct. Yeah, do everything by yourself. And if you can have questions, discuss with your classmates, ask tutors, or ask me. When you discuss with your classmates, you could do like email them or call them, but I do encourage you to discuss over Pizza so that I can observe and I can point out if anything went wrong, including the idea is wrong or the way you discuss is wrong. By the way, don't paste your code on Pizza, either public to the whole class or private to us, because even it is private and only the tutors and me can see the codes, we would not be able to offer any specific suggestion on top of that. Okay. So that's pretty much for the miscellaneous, and let's go back to one more thing. There are students who asked questions about this figure, and as well as the definition of data curation. I will answer this question, I think almost by the end of today's lecture, because we're going to give a little bit more details about data curation, and then I can come back and explain this figure while you would have a better understanding of what is curation and what is data variation. Okay? So in Monday's class, we have explained the volume, variety, and velocity. So today we will start from veracity and variability, visibility, and we will conclude the 7 V's with value. Then we will introduce some real applications of big data, and then we will introduce some big data, some operations in big data management, or a brief introduction of big data management. Okay, that would be basically all for today's lecture. Okay, now let's start. So veracity. Veracity refers to the quality of the data, or the reliability, or how uncertain the data is. So apparently, when we're talking about data, we want a large quantity of data, which corresponding to volume. But if the quality of the data is not good, then it is meaningless to have that much data. Therefore, we do want data is real and representative, such that more data would lead to more reliable models, and therefore better results in big data management. In big data applications. That's why there are some people argue that veracity is the most important V in big data. And also, if you search in Google with 4 V's in big data or 5 V's in big data, despite volume, velocity, and variety, you would see veracity in 90% cases. Veracity is directly to the trustworthiness of the data. Hence, can we trust the answers to our queries or the prediction results derived from the data? If the data is dirty, then the result would be misleading. So that could cause a series of problems, such as the loss of revenue in financial or business applications, or the credibility and customers, loss of credibility or loss of customers as well, or other disastrous consequences. Here we use machine learning with big data as an example, as nowadays there are many applications relies on deep learning or machine learning predictions, and we all know that if we want the machine learning model works well, then we would need sufficient training data. So it looks like the volume of data is important to machine learning models. However, if the training data is not enough, we would be able to know it is not enough. And then we can use simpler models. For example, we can use simpler models. For example, there are less parameters to learn, which typically requires less training data. Or we can use other techniques such as transfer learning, or use semi-supervised learning or bootstrapping to deal with this lack of training data thing. However, if the training data is not accurate, it is likely that we won't be able to know it, and it will affect the performance of the trained model, either make it overestimated or underestimated. Both is not good. So it is preferable to use less data rather than using more data but with poor quality. So just remember, only trustworthy data can add value to your analysis and your machine learning models. Unfortunately, the quality of data is not always high. In fact, when we're talking about big data, most data have low quality. For example, in this chart from source from IDC and Cisco, we can see that the volume of data is rapidly growing from 2005 to 2015. For example, in 2015, almost more than half of the total data comes from social media and the sensors from Internet of Things. On the other hand, the uncertainty of this data is quite high. As shown in this figure, the uncertainty of social media data is more than 30%, and more than 60% of census data is uncertain. The enterprise data, the situation is better because we have standard solutions to handle such kind of data. For example, the ETL model stands for extract, transform, and load of the data. This somehow guarantees the quality of enterprise data. However, in social media and Internet of Things, the data are usually unstructured, and the high velocity of data, especially in Internet of Things, leaves us very little time or even no time to perform the traditional ETL model on it. Therefore, the quality of data is hindered. This figure lists some of the sources where the uncertainty. We can see that some of these uncertainties comes from human beings. For example, the software bugs or human errors. Some comes from the nature of the data, for example, the statistic biases, lack of data linkage, or untrustworthy data sources. And some comes from the requirements of the applications. For example, the information security. It somehow forces the data to be a little bit uncertain. Therefore, you cannot avoid veracity. All you can do is try to identify the problem and to either overcome it or find another way to go through it. So the veracity problem is challenging in big data because, first of all, it is easy to occur because of the other V's. For example, volume. There are more data means even the mistaken ratio is the same, it will bring more mistakes or more uncertainties. And variety of data comes from different sources, then there definitely would be conflicts, and the quality of data is less controlled. The velocity, because data is generated in real time, so definitely the accuracy and consistency would be sacrificed to cope with this real-time generation requirement. Okay, so veracity is easy to occur, and secondly, it brings huge effect to downstream applications. So this Google flu trends example is quite famous in big data. So basically, Google released this Google flu trends product to predict the trends of flu in United States. This research is done by Google and CDC, and the data comes from multiple resources, but mainly comes from the records of flu-related search terms entered in Google's search engine. Of course, some machine learning models are used here to make the prediction. And in the spring of 2013, the flu is overestimated. The peak level is estimated as twice as the real CDC data. And one of the major reasons behind that is the searches of flu or flu symptoms may well be researching disease symptoms that are similar to flu, but are not actually flu. That's why this prediction is overestimated. And this costs extra money and the stock of medicines in that year. Okay, so the huge effect to downstream applications of brought by veracity. And last but not least, the veracity is difficult to control. So in order to control the errors, you first need to identify the errors, then you try to handle it. But when you try to identify the errors, you would find that there are too many data, especially for those real-time applications. So how to automatically and efficiently do it, that would be a problem. Also, some data is some errors, as we introduced before, is hidden in the nature of the data. So it is not that easy to be identified. And in order to handle the errors, there are at least two ways to do it. Either you can correct the data, or you try to eliminate the effects that brought by the veracity of data. If you choose to do the correction, then there's no guarantee that you can correct all the errors. Also, the workload is quite heavy. If you try to eliminate the effects, for example, to a machine learning model, then you would need a domain knowledge or expertise in related area. And again, for both of them, how to automatically do it would always be a problem. So that's pretty much for veracity. Now let's move to next V. That would be variability. It looks like the variability and the variety, they sound like similar to each other, but there are certain differences. Let's use ice cream as an example. So when you walk into a ice cream store, you would see a lot of different flavors. So this different types of ice cream is variety. So they are all ice cream, but they have different flavors, different color, maybe different price. Okay, and for variability is when you buy the same kind of ice cream in same shop. Okay, and on Monday, you find the ice cream is good. On Tuesday, you buy it again and it tastes not good. On Wednesday, you bought the third one and it tastes just okay. So although they're same vanilla ice cream from the same shop, they taste differently on different days. This is variability. So when we talk about big data, variety is we have the same object, but we have different types of data. Like we mentioned before, for one same customer, we have data related to him and profiling him from different angles. That is variety. Variability is we have same data, but the meaning of the data is changing, it's different. That is variability. The thing is, the meaning of data is changing all the time. Let's use a sentiment detection task as an example here. So here are two sentences. It seems like a review to maybe a restaurant or a shop. Let's say a restaurant. So the first one says this is a great experience. So it is positive. And the second is great. It totally ruined my day. So this is a negative review. However, if we look at the term great in both sentences, they're the same. But the meaning of great is totally opposite. This is a good example of variability. And this required us, for example, in this sentiment detection task, we should not only focus on the term itself, we should focus on the semantic of the sentences. So that required us to have a deeper understanding of the data. In order to tackle that problem, we need to make use of the context of the data. For example, in second sentence, we not only see great, but also we see ruined. So that means this great might not be a positive attitude. Now the next V in big data is visibility. So visualization or visibility is the most straightforward way to view data and hopefully understand the data. This is a result of a survey regarding to data visualization. So when asked about the benefits of data visualization, 77% people think it improved decision making. And it is also helpful for data analysis, for information sharing, for provide self-service capabilities to end users, to increase the return on investments, saving your time, reduce burden on IT. So visualization is very important. But the problem is always how to capture and properly present the characteristics of data. What to present and how to present them. That is the key part of visibility. Everyone has been using some graphs or charts to represent data, to visualize data. But simple graphs are only the tip of the iceberg. So there are many different types of data visualizations, and they are serving different purposes. For example, a line chart would be good to represent the trend of the data, and histograms on the other hand shows the distribution of the data. A highlight table may show the correlation between between two dimensions of data. A wage stack graph shows the hierarchy property behind the data. And heat map, the information is coupled with geometric informations or spatial informations. The word cloud, that's a kind of infographics. We have used it before to show the frequency of terms in different texts in order to show their importance. And finally, the dashboards is a combination of all the above, the different types of charts or graphs to give you an overall and comprehensive view of data. So why is visibility challenging? The most important thing is to choose the most suitable way to present data. In order to do that, one needs to know the characteristics of data. So you should understand data. And you should know the purpose of your presentation or the purpose of the visualization of data. Who this data is represented to and to serve what purpose. So you need to understand data, you need to understand your task. Then it is possible that you can do a good data visualization. Choose a proper way to present proper data is kind of an art, and hopefully we will show more examples later. Okay, all right. and the difficulty of data visualization. The difficulty actually comes from different perspectives. For example, high-dimensional data is hard to visualize because usually we see things in 2D or 3D we can understand, but high-dimensional data lies in a dimensionality much larger than 3. There's no way that we can either understand it or even present it. So that requires us to do so-called dimension reduction, while you project the high dimensional data to low dimensional spaces, and you still try to preserve as much information as possible, and to show this kind of data in low dimension to the end users. And another example is unstructured data. For example, texts. If you just print out all the texts you have, or all the documents you have, it is definitely not a good idea to make them visible. So in order to visualize text data, we need to first of all clean the data. For example, remove the capital letters, turn the capital letters into lower cases, and remove some stop words. Then we need to decide what to present or how to present. Depends on the purpose of the presentation. For example, we use word cloud to present the frequency of the terms, to vividly see the importance of the words. A chart of frequencies would serve the similar purposes. And sometimes we want to show which sentences have positive verbs and which sentences have negative ones. Then we can use colored features. Basically, we highlight the text that contains the features that we want to highlight it and show it. Scalability. Well, it is easy to show 1 point or 10 points, but when the point comes to 10,000 or even millions, then basically you would see all the points squeezed together, and you can barely see them clearly. The scalability also reflected by the case that regarding outliers. Outliers means, for example, you have points like this, but suddenly you would have a point here. So if you want to render this figure into a smaller size, then basically it would turn to be something like this. And it looks like here this curve is horizontal. However, there is an angle here. Okay. And finally, dynamics. So data is changing all the time, and how you manage the visualization of data to incorporate this dynamic thing or to reflect this dynamic thing, both would be difficult. Okay. All right. Now it comes to the last V in this lecture. Okay, not in big data. In big data, we have a lot of V's, of course. The value. Basically, big data is meaningless if it does not provide value towards some meaningful goal. The idea behind processing all this big data in the first place is to bring value to the problem at hand. The value comes from other V's, for example, volume. You have more data, then you would be able to have a deeper understanding and train a better model. That is the value. The variety, data comes from different sources. You integrate them together, or you make use of them together to enhance your model or to help you make the decision. That is the reflect of value. The velocity, for example, in Internet of Things, you would have data from devices, sensors. Then you make use of them in real-time applications such as surveillance systems or in homeland security. This is the value of big data, and of course the value comes from other V's as well. The value is also coming from applications of big data. That is a more straightforward way to show the value of big data, I think. We will wrap up the 7 V's in big data first, and I will show you a couple of examples of big data applications. By then, you would have a better understanding of the value of big data. So, to summarize the 7 V's in big data, the fundamental V's are volume, variety, and velocity. Volume is the scale of the data, it's how many data you have. Variety represents the diversity of data. The velocity is the speed of data. The speed of data refers to the speed of data generation, also the speed of data processing. And there are other characteristics or difficulties in big data. For example, the veracity is the quality or the uncertainty of data. The variability is how the meaning of same data changes over time. And some V's has more close relationship with big data tools, such like visibility. So you would need different tools to represent or visualize data. And all these V's, or the whole big data thing, is to serve the objective, which is the value of big data. Okay? And, well, there are many other V's. Here, we don't have time to go through all of them, but I've tried my best to show you those V's that I think are most important or most relevant to this course.